The quality of chemicals in the environment can be monitored. This is for Unit C, Environmental Chemistry, Section 2.1. And it's important to monitor chemicals in the environment because the chemicals are going to impact ecosystems, they're going to impact living organisms. And one of the major things that scientists monitor is the water quality. Now, at first glance, if you see a clear and colorless bottle of water or a clear and colorless body of water, you would automatically assume that that is safe water. Perhaps it's safe to drink. But clarity is not a good indicator of water quality. Sometimes it's really easy to see that water quality is diminished. For example, lakes may become cloudy in the summer because of excessive algal growth due to the runoff that contains many phosphates, and that will reduce the overall oxygen content inside the lake and reduce the oxygen availability to the fish and flora of that lake and impacting the ecosystem severely. But the important thing to consider when you're talking about water quality is water quality is measured with respect to what the water is used for. And we use water for many reasons. The five main reasons that we talk about are to drink, so humans can drink the water. We use it recreationally. So, for example, when we go swimming in a pool or swimming in the lake or in the ocean, livestock drinking water. So we use water to hydrate our livestock, for example, cows and pigs and other animals that we farm. We also use it for irrigation. So in other words, irrigation is a fancy word for saying, just watering your crops or your plants. And of course, we use water to protect aquatic life. Now, when we're measuring water quality, there are many ways of doing it. There are both biological and chemical ways of doing it. With the biological indicators, we can use how some organisms are living in the environment and how they change. Microbiological indicators as well also do the same thing. But we also look at chemical factors, and this is what really this video is all about. This video is intended to help my students or anyone else who might see this to calculate a very basic way of calculating parts per million. Of course, if there's anybody out there who's taking a little bit more advanced chemistry, there are other ways of doing it, but this is just the basic and hopefully a simple way of calculating parts per million. So typically you'd have to understand what 1 part per million is, and I took these slides out of my notes, so this probably doesn't have, like, this first sentence here probably doesn't mean a lot to you, but definitely the one in blue explains it very well, that 1 part per million means that 1 unit of an element or chemical can be found in 1 million units of a solution. So, for example, let's just say if we had let's say we had 1,000,000 golf balls, and we took one of those golf balls and we painted it, we painted it red, and we put that back into the mix. Well, we could say that one golf ball out of the million is red. Okay, so that's kind of what a part per million is. Units don't really matter when you're talking about, as long as they match up. So if you're talking milliliters to milliliters or liters to liters, it doesn't really matter as long as they match up. But that's essentially what a part per million is. And we'll get into showing you how to calculate them shortly. So I haven't gone over this in my class just yet, but this is a demonstration I intend to go through. But so if you have 999 milliliters, which is close to a liter of water in a beaker, and you add 1 milliliter food coloring and you make a solution when you stir it. Now, the thing you have to understand, and I anticipate this is where people can make a lot of mistakes, is you have to be careful with the step here. Calculating the volume of the solution. Solution is the key word here, okay? Because in this example, we have 999 milliliters of our solvent, which is water, but we're adding solute, which is the food coloring. The total solution is going to be the volume of the solute plus the volume of the solution. And that is what you have to add when you that's what you're going to have to substitute in your volume of solution. So typically I anticipate students would just like, oh yeah, okay, 999 milliliters of water, let's just plug this number in here, right? But that is incorrect. That's not what you want to do. Okay, the volume of the solution in this case would be what? It would be 999 milliliters plus 1 milliliter, so it would be 1,000. Okay, it'd be 1,000 milliliters. Okay, so that's something to note and be careful about when you're doing these problems. Okay, so here's the formula again, and essentially this is a ratio. So whatever volume of solution you get, you have to ask yourself one question. I've tried to show my students how to solve this mathematical equation using the crossover method, and I find that the crossover method actually confuses a lot of people. I use it all the time. It might work really, really well for you. In fact, it works best for me, but I find what works best for students is this method here. It's just to kind of explain it as a ratio. Cross multiplying, of course, is just multiplying these two numbers with these two numbers and setting an equation without any numerators and denominators, and just kind of solve it linearly that way. But this method here that I've started works for students. So what you have to do is you just have to take the volume of the solution that you get and ask yourself, well, how do I get from this volume to 1,000,000? Do I have to divide it by a number? Do I have to multiply it by a number? And once you figure that out, typically to get the answer, you would take 1,000,000 divided by that number, and you would get the factor you have to multiply it by. And once you get this number, we'll just call it n for now, you would take this number and you would apply it to the top, because whatever you do to the bottom, you must do to the top. So you multiply it by n, whatever that number is. Okay, but now I think we're going to go ahead and do an example. Okay, so here's an example problem I just kind of made up. It's not too difficult. Hopefully this will make sense. So you add 5 milliliters of chlorine to a 1,095 milliliter, 1,095 milliliter water in a container. How many parts per million of chlorine is there in the resulting solution? Just take this out. Okay. So one thing you have to remember is your formula. And I just kind of put that here in the corner, and we can work through there. Now, what I teach, a good way to do problem solving for any mathematics that you're doing in science is you do a three-pronged approach. You do like 3 steps. So 1, 2, and 3. Oh, yeah, that's a 3. And the first step, you should always just highlight your variable so that you know what it is you're working with, and that can guide you to picking the right formula from your data sheet. And I call this step like making your variable stack, right? So in this case, I find my volume of solute, right? And I'll just abbreviate it as SOL. Actually, I'm not going to abbreviate it. E equals, okay, 5 milliliters. Okay, and my volume of solution, SOL, is equal to 1,000. No, this is the tricky part. 1,095 milliliters. Okay, and I'm going to add that to my solute, because when I put it in, I'm going to stir it up and get a solution, right? So I'm going to add that to 5 milliliters. Okay? And that's the tricky part. That's where people can make mistakes. So that should give me a nice round number, 2,000 milliliters, which is equivalent to 2 liters. So that's my first step. My second step is actually rewriting the equation, which I'm not going to do because it's kind of hard to write with this, with my mouse. But that's what you would do. You would rewrite the equation, substitute the values that you have identified or have made equal to in your variable stack, substitute them into their respective locations, and solve the problem. So I'm just going to go ahead and do that. So my volume of the solute is 5 milliliters. Okay, I'm going to divide that by my solution volume, which is 2,000 milliliters. I'm going to make that equal to x, our unknown, divided by 1,000,000, 2, 3, 4, oh boy, 5, 6. Okay, that's supposed to be 6 zeros. Anyway, so now I ask myself, how do I go from 2,000 to 1,000,000? Okay, and how do I figure that out? Well, if I just do a quick little calculation here and I take 1,000,000, okay, no, one more zero, 1,000,000, right? 1, 2, 3, 1, yeah, okay, divided by 2,000, right? And if I do that calculation really quick, I would get, so yes, if you were to divide these two numbers, you would get the factor of 500. Okay, so to go from 2,000 to 1,000,000, if I did this correctly, it would be 500. Okay. Okay, so now that you know how to go from 2,000 to 1,000,000, what you do to the bottom, you have to do to the top. Okay, so we're going to go 5 times 500. Oops. Okay, so that's what you do in your second step. You just show all your work. And your third step here, okay, is when you report your answer. And of course, you're going to report your answer with the proper units. Don't forget your units. Okay, in this situation here, we're going to be reporting it in parts per million. Okay, so we take 500 and multiply it by 5, and we should get 2,500. Oops. Parts per million as our answer. And what I always tell people is it's a very, very good idea to just put a box around your answer and just let your marker know that you got the answer and this is the answer you're sticking with. Okay, I hope that helps, and that's how you calculate parts per million.